which doesn't affect people who showed up to class, but I somehow ended up only recording half of it. So, so for the people that missed it, I'll review a little bit of this stuff again. I might just go a little faster. Okay. And this might be good for everyone, regardless, right? Even though we already did this last time. So basically, right, we're all learning propositional logic. Propositional logic. So logic is just a way of figuring out if a deductive argument is valid or invalid. Yeah. Okay. And so we're starting to learn how to do it, right? So I'm showing you what the basic pieces of the game are, and I've told you what the main objective is, right? Find out if any given argument is valid or invalid. And you're going to do that using these basic pieces, these basic bits and pieces. So we learned about statements and operators, right? Where a statement can just be translated into P's and Q's. And an operator is a word like or and, or not, or if then. Right? Those are the four operators we're working with. So if the term operator scares you, at least know there's only four of them, right? And also know that they are ordinary English words that are going to function as they ordinarily do, but maybe a little bit more rigidly, because everyday language permits a certain amount of vagueness or ambiguity. Right? We'll try to get rid of that when we really define all the terms. But right now, all you have to think about is, you use these kinds of sentence constructions in everyday life all the time. You'll say things like, well, I'm going to do this or that, right? And when you say that, you're basically saying there's two things involved, right? There's one statement and another statement. Each of them is individually capable of being true or false, right? You either move to France or you don't. You either move to Spain or you don't. But then you also have the whole sentence as a whole, the big complex statement, where two simple statements are being bound together by this operator, right? And then the big statement has its own truth value, right? In an or statement, the or statement could be true even if one of the simple statements is false, right? If I tell you that I'm going to either move to France or to Spain, and I end up moving to Spain, you're not going to say, wait, you told me something false. You said you would move to Spain or France. I would say you don't understand what or means. Or means I'm going to do at least one of these two, right? And I did. I went to Spain. I didn't go to France, so I will move to France. False, right? I will move to Spain. True. The whole statement. True. Because in an or statement, in a disjunction, you only need one of the two things to be true. Whereas if I said I will move to France and move to Spain, then I'd have to do both, right, in order for the sentence to be true. So that's just I'm relying on your intuitive grasp of the English language, that you understand how or and work. And if then, it's the same sort of thing, right? There's two different components to it. Socrates is human, and Socrates is mortal. Each of those can be true or false on its own, and then the big statement, the complex statement, can also be true or false. Okay, let me skip over some stuff. All right, so these are the four operators. So the symbols, right, they just mean these ordinary, everyday English words, right? And we use the and symbol to represent and, the little V to represent or, and to help remind you what that is, you can look at the V like this, as though there's two choices, either this or that, right? A little V, one or the other. And then we have the if-then type statement, where we're saying if this statement is true, then this statement is true. That's what conditionals, if-then statements are like, right? They're not saying that either one of them necessarily is true. They're just saying that if this is true, then this is true, right? And so we have a little arrow to indicate that A always leads to B, for example, right? If statement A is true, then statement B is true. Or if statement P is true, then statement Q is true. And we use this in our everyday reasoning. And as I mentioned last time, this is a big part of computer programming, right? So when you learn propositional logic, this is very, very close to what's called Boolean logic. And Boolean logic is what basically makes all your software run, right? So you're learning to think like a computer, right? In a very well defined way, in such a way that you're able to recognize when an argument is valid, right? And an argument being valid means if the premises are true, the conclusion must be true, logically speaking. Okay. So the conditional, and then the not operator, right? The negation, which basically just negates whatever you're saying, right? So I could say Socrates is wise, but I could also negate that whole statement and say Socrates is not wise. Right? Again, just everyday English. We do that whenever you use a negation. There's always some positive part that's part of your statement that you're negating, right? You're saying, well, this is not true, right? But when you sort of present the this is just a positive statement without the negative, right? So when I say Socrates is not wise, there's a basic component there that says Socrates is wise. And I'm negating that with the not. I'm saying that's not the case, that Socrates is wise. If I were to say such a foolish thing, right? Socrates is the wisest of all beings. The oracle at Delphi said so. If you don't know what that means, then take my intro class to philosophy. Okay, so we use variables, right, just like you do in algebra. So if you have just a simple statement without any of those operators, without and, without or, without if then, without any of those four operators, like this simple statement, Socrates is wise, if you wanted to put that into symbolic logic and propositional logic form, you can just pick any letter that you want. Right? You can pick W. You don't have to. I just picked it because that's the first letter in wise. Right? Sometimes it's nice to remind yourself of what the sentence originally was. So then what you would do for any given sentence, you would look at it and try to think, is this a conjunction type statement? Is this a disjunction type statement? Is this a negation, or is this a conditional? Then depending on what they are, then you zero in on the individual simple statements and use P's and Q's for those, and then you use the symbols like the ampersand or the little V or the little squiggle or the arrow, right, to represent those operators. Right, so if you wanted to say this, now I know this is all review, but I don't mind. I think it's not a bad idea to do it. Okay. Especially because like I said, some of the video got cut off. So I want to make sure I cover everything for the people that can't make it to these meetings. Right. So Socrates is either wise or immortal. This might look like it's a simple statement because you just have Socrates and there's just one verb, is. But when you really think about it, there's really two statements going on here as well. It's just below the surface. Our grammar sometimes hides what's really going on, right? There's really two separate statements here. Socrates is wise, Socrates is immortal. Yeah, and then you could symbolize it like Maggie just did. If you look in the chat, people watching the videos can't do that, of course. But she wrote S little v I, right? S can represent Socrates is wise, Socrates is immortal, can be represented with I, and or is represented with the little v, right? To signify there's two choices. Right? Socrates is wise, Socrates is immortal. Right? So this is what you get. And notice that it does not matter which variables you pick to represent the sentences, right? So Maggie had the Socrates is wise represented by an S. That's just fine. As long as you're keeping track of what everything stands for, you can pick your own variables. You can't pick your own operators, right? We're going to use the same for the whole time. We're going to use the ampersand, the V, the squiggle, the tilde, right? And the arrow. So Maggie correctly had two different variables and then the operator, the or operator right in the middle. Perfect. This example, very similar. There's two different statements, right? The music was loud and the alcohol was flowing. and we notice that there's an and there, so that's one of our operators. So we're going to symbolize the operator separately from those simple statements. All right. So again, pick any letter you want for the individual statements, for the individual simple statements. And again, a simple statement is one that does not have any of the operators in it. Right? So the complex statements are going to be simple statements with an operator. So if we do this with this and statement, we get something like this, right? Again, you could have picked different variables. You could have picked not M or A. You could have picked N and B or P and Q. It doesn't matter. As long as you have two different variables to stand for the two different sentences, and then the and right in the middle to represent the operator. Do the same thing with an if-then type statement. If it's raining, then I want to go outside. There's two different statements going on. It's raining and I want to go outside. And they're being joined by that operator. So the operator needs to be represented with the little arrow, of course. And each of the simple statements need to be represented by a variable, like P and Q. And then join them with that conditional, and you get this. Okay? Yeah, Anna, that's right. Yeah, you could have done R arrow O, right? R for raining, O for outside, right? Yeah, exactly. Good. Yeah, you're getting it. Yeah. Of course, these are just simple examples, and we'll go on from there. But that's why it's so crucial to get this first level, as it were, right? And we did this, and I think we had our exercises. But like I said, I'll go over everything. It looks more complicated than it is. Yeah, it's really true. It's really true. Yeah, if you go slow, then it all makes sense. Now, that said, even if you understand how it all works and you start working with bigger equations with a bunch of symbols, that can still feel overwhelming, even when you understand how it works. That's just part of the phenomenology of it. Yeah, it is like algebra. But I don't think it's as difficult as algebra myself. I really don't. It doesn't really require you to be good with numbers. You just have to remember the rules. And there's a very short list of rules to follow. So the gnome is not drunk today, right? I hope you enjoy my random examples. I try not to think too hard about them because then I get stuck and I can't come up with anything. So a lot of times for these examples, I just have first thought, best thought. So if I think the gnome is not drunk, then that's what I'm going to write. I don't know what it's talking about. It doesn't mean anything, right? The simple statement is the gnome is drunk today, right? Because, again, simple statements are statements without any of those four operators. So without if then, without and, without or, without not. So if we look at the gnome is not drunk today, that statement is a complex statement because there's a simple statement and an operator, right? The not operator. So the simple statement, you simply subtract the operator out of it. What are you left with? The gnome is drunk today, right? So, yeah, so Anna, so either you or somebody else did the same thing last time. Maybe you're about to correct it. Yeah. Very close, right? Yeah. You just don't need two operators in this case, or two variables. Sorry, you don't need two variables. There's only one simple statement, right? And the other one we had several. Yeah, then that's fine. Yeah. Well, it's hard because the not is different from the other three, right? You kind of expect them to be consistent, but the not is just a little bit different from the other ones. Yeah. It's negating one statement, right? Yeah. Well, it's good to get it early like this, right? And that's why it's good to, sort of interact when we're doing the lessons because this is the perfect time to sort of hash that out and, make little mistakes that you then get used to and then stop, Yeah. I think you'll be fine, especially now that this happened, right? I think you'll remember. Yeah, so for negations, if it's just a one little sentence like this is not the case, right? Socrates is not wise. The gnome is not drunk today. It isn't raining. Anytime you have any kind of negation in there, where you're saying that something is not true or not the case, then you simply take the
That's
thing.
not all.
Try to get.
Oh, what the heck? Look,
I did a nice little 30-minute side bakes even though I wasn't supposed to.
Jaden,
Got the,
look
like,
at Jaden wants to show you his
like the
handstand.
gas
Go,
pedal.
show Adonis how to do that.
Somebody's mic is on really loud. Somebody I hear them talking. Okay, that was pretty funny. It's Alyssa. Okay, not a big deal. I liked it.
I'm so sorry. I have some crazy, wild little brothers that don't leave me alone.
No problem. I got it. Okay, the gnome is drunk today would be the simple statement, right? And then you put the operator in front of it and say not D or not G or not P, whatever you want it to represent the gnome is drunk today with, right? So negations, even though they are simple, sometimes they're a little bit tricky. You might wonder how to do it. Well, again, just take the not out of it, right? What are you left with? You're left with some sort of positive statements, right? Whenever you have a negation and you take the negation out of it, you're left with a positive statement. And that's your simple statements, right? And then you put the negation back in as a squiggle. Yeah? Does that make sense? So far, not thinking ahead too much, but so far what I've covered, if there's some sort of thing that's not quite gelling, that's not quite crystal clear, please bring it up, One of the hardest things about teaching, it's called the curse of knowledge. There's a word for it. In this case, it means the curse of not knowing what you know, right? I can't know exactly where you're at, right? Exactly how much of it you're getting, what your background information is. I have to make assumptions about that, but I cannot do that perfectly. No teacher can. So it's so imperative to get feedback back from you in order to put me on the right track, right? So that I can understand where you're at. So I'm just leaving that open as an invitation, right? I wouldn't take that as a criticism. I wouldn't take that as reflecting badly on your ability to do the work. It wouldn't be anything like that. It would just be, I want to be able to orient myself appropriately given what the class sort of knows. And of course, that's going to be different for each individual as well. So it's a very, very difficult task. Anyway, I'm just saying, remember that I've got an open invitation for you to give me feedback, questions, stop what I'm doing, whatever it may be. As long as you don't overthink it, yeah. Some of the stuff in the middle of the course, like stuff we just did a little bit earlier, right? A lot of that is leading up to this, yeah. So if maybe you're talking about argument and argument structure and things like that. And we'll review those again as well before the midterm. I want to see what you're typing. Yeah. Oh yeah, if time is an issue, that's difficult, of course, right? Yeah. Yeah, and Maggie says that what you do in class, and it is really important because the textbook has a lot of stuff, and you always sort of have to decide what you're going to focus on. So to get a better idea of what I'm going to test you on, it's really just the class is primary. My presentations are the primary thing that you should be following, and the textbook is there sort of as a backup. But if you're just looking at the textbook, you might become overwhelmed with what you think you're supposed to know, right? You might think, am I supposed to know everything that's in this textbook? And the answer is not necessarily. If you focus on what I teach in class, and then you're reading as sort of a supplementary thing, you're going to have a much better idea, and you're going to be much more prepared for what I'm actually going to quiz you on. Okay, so we left off on 4. What's one way that you could represent number 4? these exercises aren't boring at all? Well, first of all, what's the simple statement? Don't write it as a variable yet. Right? What's the simple statement in this complex statement? Remember, a simple statement is just the statement that's there without any of the operators. Let's see. Oh, you're doing, Anna, you're correct about number one. Yeah, no, that is correct for number one. But I was skipping that one because we did it last time. So I'm on 4. We did 1 through 3. But you are correct. Those are the simple statements for number 1. Right? It's sunny. It's hot out. Yeah. Yeah. What's the simple statement in 4? Well, first of all, what kind of statement is it? Right? Is it a conjunction, a disjunction, a negation, or a conditional? It is a statement, but there is also a negation in there. Yeah, see, because it says aren't. And again, sometimes I do this on purpose. I sort of hide it in everyday English, right? We use contractions and things like that, but there's still a negation going on, right? Someone's saying these exercises are not boring, right? So if you take the not out of it, what are you left with, right? If you take the operator out of a statement or out of several statements, you're left with the simple statements, right? So if you take the not out, what would you be left with? Oh, I see. You all just don't want to say these exercises are boring. I get it. You know, you don't want to insult me, right? The simple statement is these exercises are boring, right? That's the simple statement. So if you were to do the exercise, how I said it, not for number 1, right? It says write the simple statements separately and assign variables to them, right? So for that, I would do something like these exercises are boring, and that I'm going to say equals B, right? These exercises are boring equals B. That's what I would have done for the first part, right? Write the simple statements separately and assign variables to them. Yeah, that's right. You take it out to get to the simple statements. Yeah, exactly. Yeah. So you end up with these exercises are boring, that's B, but now we need to put that negation back in. And maybe you're typing what I'm about to write. Yes, exactly. Yeah, you got it. Yeah. You get something like not B, where B represents these exercises are boring. But then when you read the whole thing, you have a negation in front of it, you know that means it's not the case that these exercises are boring. Otherwise known as these exercises aren't boring at all, right? So you're formalizing it all, right? You're sort of looking through the surface vocabulary and you're seeing what's really going on. And you see that there's a simple statement there that's being negated. So you represent the simple statement and you put the negation in front of it. Yeah, aren't, right, exactly. And I do that on purpose, right? So that you have to pay attention. You have to ask yourself, what is this sentence doing, right? And keep those 4 operators in your mind, right? Is this sentence giving me a disjunction? Is it giving me a choice of 2 things? Or is it giving me a conjunction? Is it saying that 2 things are true? Or is it giving me a conditional where it says, well, if this is true, then this is true? Or is it negating something? Is it a negation? Is it saying that something isn't true, right? And whenever you have any sort of are not, isn't, anything like that, it's a contraction involving not, right? So there's a negation there, even though it can seem to be hidden. But of course, if you just look at the statement, you realize that that's what's going on, right? These exercises aren't boring. Yeah, it's negating something. It's negating the idea that they're boring by saying that they're not. Okay. I'm grumpy and you're drunk. So again, if you're still having a hard time knowing what the simple statements are, just take out the operator if there's an operator, right? Is there one of these four operators going on? Is this one of those sentences? Is it a conjunction, a disjunction, a conditional, or a negation? Yes, it's a conjunction, right? And if you can't remember the word conjunction, you could say, oh, it's an and statement. That works as well because you're letting me know what the operator is. But yeah, it's a conjunction. So, take out the conjunction, you're left with two simple statements. There you go. Yeah, and put it in the text, right? That's one way to do it. That one simple statement is, I'm grumpy, let that equal G. You're drunk, let that equal D. And then the and to represent and, right? And you end up with G and D. Simple. What about number 6? Is it a conjunction, disjunction, conditional, or negation? Yeah, it's another negation, right? So now maybe we're getting a little bit clearer on how this would work for a negation. What's the simple statement that's being negated? Good. Yep, you're getting it. Yep, that's right. It sounds kind of weird. Right? The sentence says, I don't know what that liquid is. So it might feel weird to you to say, when I say, what's the simple statement? You have to say the opposite of what it says. But then, of course, you're putting negation back in afterwards. So you end up with something like not L, right? Tilde L or tilde K, however you wanted to represent it. Tilde X. The simple statement is, I know what that liquid is. The complex statement is, I don't know what that liquid is. It's not the case that I know what that liquid is. Okay, good. Wait, we don't have to go. Let's see. So 7 is a little tricky. Okay. I did not use the actual words that you often see in one of these for these operators. But sometimes we know how to say things with different words, right? The English language is capable of that as well. And there as well, when we're doing propositional logic, we want to put it all in if-then form. Even if the original sentence does not say if-then, right? So here's an example of that. I'm sort of giving it away here. But do you see what's going on in 7? Yeah, provided is a key word, because what is provided a euphemism or a synonym for? Yeah, if. Exactly. So this is actually a disguised if-then statement. And remember, we want to put it in the correct order for if-then. Right, so if we were to translate this into an if-then statement, really what you'd have to say is, if technology advances far enough, then our concept of transportation will have to be redefined at some point. Okay. I know it's a mouthful, but it's basically you're still just saying if P then Q, right? It's just that we had to switch it around. So the simple statement that you put first is technology keeps advancing, right? Technology advances far enough, right? If technology advances far enough, right? T, then arrow, our concept of transportation will have to be redefined at some point. So technology advances, right? Dot 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 equals, let's say, T, and our concept, I don't want to write it all out, dot 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 equals C. And then you'd end up with, yeah, but just not, Stacy, first you have what's called a biconditional, and I'm going to make sure not to do biconditionals. So you only want it pointing one way. Like that, right? So T, arrow, C, And notice T stands for technology advances far enough, right? Which in the sentence comes second. But logically, as an if-then statement, we're going to have to put it first. Yeah? It's the antecedent. Technology advances far enough is the antecedent. And the consequent is our concept of transportation will have to be refined at some point. Okay. Yeah. The arrow means implies, right? Yeah. So you can think about it in different ways, right? Technology advancing far enough entails that our concept of transportation will have to be redefined, right? That's one way to put it. So I put it in there just to show you that something can be an if-then statement, but using slightly different language. Something can also be an if-then statement, but when it's originally written, they end up putting the antecedent last, right? So for this, you just have to keep your own critical mind ready to understand the internal logic of the sentence, right? So first, just rearrange it as using the word if, right? So you could have just done that. Our concept of transportation will have to be redefined if technology advances far enough. Well, then you realize, okay, I've got the if. I always want to put if first because I always want to make sure that we do it in if-then format, right? So then you simply switch it. You simply put the if part first. If technology advances far enough, then our concept of transportation will have to be redefined at some point. Notice it means exactly the same thing, right? We haven't changed the meaning at all, and that's really important. You don't ever want to change the meaning of what someone is saying. But here that means exactly the same thing, right? We just put it in this format that allows us to do logic, right? We're putting it in this if-then construction because we're going to rely on the if-then operator. And we want to make sure that it follows the rules correctly. So we just want to put everything in the right order so that we can play our game, right? So sometimes you just have to get the stuff ready in order for it to fit into the system. Yeah, you need to always be careful of the wording. Don't change the meaning. Now, and or statements are always going to be pretty simple. They're going to use the word and or. But conditionals will sometimes show up with different words, right? And you just have to sort of be aware. Is this trying to say that the truth of one thing relies on the truth of another thing? Right? Because that's what makes the conditional kind of unique, doesn't it? Right? With an and or an or statement, it doesn't really matter, right, which side is true or false. There's no dependence of one statement on the other. But in a conditional, what you're asserting is a dependence. You're saying, this is true if this is true, right? Or if this is true, then this is true. You're saying there's a relationship between these two statements. So if that's what's going on, you're probably dealing with some sort of if-then statement. So then you'll just want to translate it into that format, making sure that you put the antecedent first and the consequent second. Because it's a huge difference if you switch them around, right? If I said, if our concept of transportation will have to be redefined at some point, then technology will have advanced far enough. It's not really the same meaning. It doesn't mean the same thing. Even if that maybe is true as well, it's not making the same claim, right? So when you have an if A then B, it matters which one you're putting right after the if, right? It matters which one's the antecedent and which one's the consequent. Okay, fine. Unless there were questions about that, I'm going to try to not make it too tricky ever, but still I have to tell you, right, that to do propositional logic, sometimes you have to translate out of everyday language. And it's good to be able to start recognizing if-then type statements, even when they're using different language. Because as you saw, you saw the two very easy ways of making logical mistakes, right? Affirming the consequence or denying the antecedent, right? We do that with if-then type statements. And sometimes the if-then type statements don't actually use if-then, but the logic is still the same. All right, so it's good to be able to recognize that. So what about 8? Is it a conjunction, disjunction, conditional, or negation? Yeah, 7 was a conditional, right? Yes. If you go up a little bit, I wrote it out, right? T arrow C, where T stands for technology advances far enough, and C stands for our concept of transportation will have to be redefined. Yeah. So T arrow C. Yeah, Maggie, 8 is an and type statement, right? A conjunction. So this would be really easy. So you have, here's a perfect example of you've got this big long sentence. If we're worried about the logic of a statement or the logic of an argument, we don't actually have to worry about what everything that it's saying, right? So you can just very easily symbolize the simple statements, which happen to be long in this case, with just a single variable, like Stacy just did, right? Letter F, right? It's going to be a long time before he shows his face. Ampersand for and then T feels terrible, right? Yeah, study each of these carefully. Now, I'm going to show you the truth table and how they work in just a second. So, we're going to move on, but it's still explaining all this more and more, okay? So if it's not totally making sense yet, hopefully it will. And remember, there's just 4 types of statements, right? Every time you feel overwhelmed, just remind yourself, there's just 4 of them, and or are not really tricky at all. You just look for statements joined by or and, right? Pretty straightforward. Negations are pretty simple too once you understand it, and once you understand, sometimes you have to look for contractions like aren't and isn't and haven't, right? Things like that. But those are not that tricky either. The trickiest ones are conditionals. Conditionals are the tricky ones in the bunch. And there's a lot more work you can do with conditionals, and that's why you can do biconditionals where they point both ways. I'm not going to make you do that. I'm going to keep it pretty simple. Okay, so those are the exercises. So now let's define those operators a little bit better. Let's really get clear about what those operators, each of them, really does for a sentence. Because remember, these operators join together multiple statements into a bigger statement, right? Especially the 3 ones that are not the negation, where you have multiple statements. The truth value of each of the individual statements is going to determine the truth value of the overall statement. But also the operators. The operators also have a lot to do with that, right? So, for example, the example we used earlier, if I tell you, I am going to move to France and I'm going to move to Spain, that's only going to be true if I do both of those things. Correct? That statement is only true if I do both. Where if I say, I will move to France or I'll move to Spain, well, that statement can be true as long as one of them is true, right? As long as I move to Spain or move to France. There's no problem with one of them being false. The overall statement is still true. Yeah? So that intuitive feeling that you have, that you get that because you understand what the words and or mean as an English speaker, right? Now we're going to formalize that. We're going to show that exactly. When is an or statement true? When is an and statement true? Right? When is a conditional true? When is a negation true? Right? So the truth of a complex statement depends on the truth of the simple statements and the way that the operators work. So if we take this one now, instead of Paris or instead of France and Spain, we talk about the weather. It happens to actually be sunny and hot out today, right? Is it hot? I know it's sunny. I haven't been outside in about an hour or so. Doesn't really matter, but it's hot. Okay, so in this case, great, right? So if I say it's sunny and hot, and again, right, this looks like it's simple, but there's actually 2 statements going on, right? It's sunny out, it's hot out, being joined by the and operator. So it's hot out, it's actually true, and it is actually sunny out. So the statement is true, right? Because both of those things are true. Now, if I had said it's sunny and hot out, but it's one of those weird humble days where It's sure it's very sunny and bright, but it's freezing. That happens, right? The statement would have been false. If I say it's sunny and hot out, but it's not hot, my overall statement is false. It happened to be sunny. I was right about that part. But I was not just saying that it's sunny. I'm saying it's sunny and hot. And in that case, if it's not hot, then the overall statement is not true. Which is different from an or statement. This time, the complex statement is true as long as just one of the simple statements is true. If I tell you it's either sunny or hot out, and you tell me that it's sunny but it's actually cold, well, I was still right. Right? I was saying, well, it's going to be one of those. Right? Well, then it's going to be true as long as at least one of them is true. And in most cases, we would say it's true even if they're both true. Right? So this is kind of a tricky part. This has to do with the difference between an inclusive or an exclusive or. I touched on this briefly last time. We're always going to be talking about the inclusive or, which means at least one of the statements has to be true. But if they're both true, hey, that's fine, right? If I say it's either sunny or hot, and you check that it is hot and it happens to also be sunny, I was still right. Right? It makes sense, doesn't it? Now, sometimes we specify, it's me or the booze, right? Not both, right? Sometimes we give this kind of an ultimatum, kind of an or, okay? But that's going to be a specialized sense, and we're not going to use it in that way. For us, or will just be at least one of the two simple statements has to be true. If they're both true, the whole statement is still true. Right? I hope that makes sense. If you have questions about that, do bring it up. That can be confusing. But for our purposes here, right, I'm saying if I tell you that it's either sunny or hot out, and I happen to be right on both counts, you're not going to say that I'm wrong, right? Like, yeah, you're right. It is sunny, and actually it's also hot. You're right about both, right? Yeah. So that's how we mean how we're going to use it. But that tells us, right, that the and operator and the or operator, or if you just want to talk about everyday English language, the word and the word or are different, and they function differently. And we can see it perfectly well right here, right? Because we're using the same simple statements, and yet the truth value of the overall statement is going to be different depending on whether you use and or. Right. So we can actually show how they do that really well by using what's called the truth table. Okay, and that sounds intimidating, but it's really supposed to just show you what you already know as someone who can use words like and or consistently, who knows what they mean. You implicitly already know these truth tables, believe it or not. So if we take this, and this might look overwhelming and weird to you, right? But by now, the P and Q should be easy to read for you, right? If we say that P represent it's sunny out, and Q represent it's hot out. So look at the first row. That first row is basically saying, or there's a little T beneath the P, right? And there's a little T beneath the Q. Does everybody see that? Just that first row. Here, let me go to the actual thing so I can highlight it for you, where I am. So I'm right here. If you can see that. So we're saying, let's suppose it is sunny out. Let's suppose that it's true that it's sunny out. And suppose that it's true that it's hot out. Okay, let me go back really quick and ask you, can you see the cursor when I was just doing it? Were you able to see the cursor? Okay. Okay, so I'm going to go back to that then, and this will look a little bit weird for the people watching the video, but I don't want to change the size of the window. Well, I can make it a little bigger, I suppose. Okay, so P represents it's sunny out, the ampersand represents and the Q represents it's hot out. Okay? So we're just looking at all the logical possibilities, right? It could be sunny out and hot out, like in the first row. Ignore this column right now, okay? Just look at the P's and the Q's. Ignore the and. Okay? It could be hot out and sunny out. It could be sunny out but not hot. It could be not sunny out but still hot. It could be neither hot nor sunny. Do you see how each of these 4 rows represents all the different logical possibilities that there are? And again, ignore the middle column for now. Just look at the P's and Q's. What these 4 rows represent is all the different possible logical possibilities, right? It could be both sunny and hot out. It could be neither sunny nor hot. It could be sunny but not hot. It could be hot but not sunny. Those are our 4 different options, right? Does everyone see that? Yeah, there are all these different possibilities. That's all we're really talking about. And remember, each P and Q can only have 2 truth values, so it's a little bit like if you have 2 coins with a heads and a tails. Will a 2-statement conjunction truth table always look like this? Yes, yeah. The 2-statement conjunction truth table will always look like this, yes. Yeah, exactly, because we're representing all the possibilities, right? So again, we have 2 statements. They can either be true or false. In how many different ways can we combine these 2 statements in terms of their truth and their falsity? Well, it's the same way as if you have 2 coins with heads or tails, right? You can have both heads, both tails, one heads, the other tails, or this one heads and that one tails. You see that? 4 different logical possibilities for each of the P's and the Q's. Yeah. Yeah, and notice it's just by convention that when you fill out the P's, you can go TTFF, and when you fill out the Q's, you can go TFTF. Then you've represented all the different possibilities that there are. Right? So it's very important that you understand why there's exactly 4 rows here. Right? Why are there exactly 4 rows? Well, it's because there's exactly 4 ways that P and Q can be true or false together. Right? The first row says they're both true. The second row says P is true but Q is false. The third possibility is P is false but Q is true. The fourth possibility is they're both false. Right? These are just all the different possibilities that there are. Now, remember what we said earlier. When is an AND statement true? If I tell you that it's sunny and hot out, what would have to be the case for that statement to be true? Yeah, both statements have to be true, right? And so that's why when you look at the middle column, okay, oops. No. The people watching the video saw my Facebook all of a sudden. Okay, let me go to here. Okay, so now when we look at the middle column, this represents the truth value of the whole statement. So the middle column represents the truth value of the whole statement, right? Because the whole statement is a conjunction, so we're putting it right under the conjunction sign. So the first row is the only time that a conjunction is true. When I say it's sunny and hot out, both of those things better be true. Right? If either one of them was false, then the whole statement is false. Right? It's hard for a conjunction to be true because both conjuncts have to be true in order for it to be true. You see that? So only the top row has a T right here in the middle. That's because a conjunction can only be true if both sides of the conjunction are true. Okay? In all other cases, they're false. I would have said something false if it's either not sunny or not hot out, or neither of them. Yes, exactly. The middle column is the truth value of the whole statement. That part is confusing. So Stacy, you're both asking, Stacy and Anna, you're both asking about the same thing. In the very first row, right? So we're just looking at logical possibilities, right? I'm saying, suppose I said to you that it's sunny and hot out. How would you evaluate whether or not my statement is true? You'd have to see if it's actually sunny and hot out, if they're both true. Right, yeah. But you have to see whether the statements are true. And if either of the statements is false, then what I said was false. So that's why only the top row, let me go back to it again. Only the top row shows the whole statement being true. Right? Again, this whole column here, underneath the and sign, is the truth value of the whole statement. Right? The whole statement is it's sunny and hot out. So if I were to ask you, is my statement true? You'd first have to check, well, is P true and is Q true? If they're both true, then my whole statement is true. But if Q is false, if one of the things I said is false, then my whole statement is false. Or if P is false, then my whole statement is false. If it's neither sunny nor hot out, then I'm really wrong, right? Does everybody see it now? When you make an and statement, you're basically saying P and Q are both true. That statement itself is only true if P and Q really are both true. You know? So the people who are saying this middle column confuses them. So let me say it again. The middle column is the truth value of the complex statement, the whole statement. Here we just have the truth values for the simple statements. Okay? Yeah, sometimes you can use different colors. You can use, instead of the T's and F's. And like I said, computer programming language uses zeros and ones, and sometimes logic does that as well. I prefer to keep it about truth and falsity because that's what we're really concerned about. Okay. So this is just supposed to show you the logic of and statements. Whenever you make an and statement, this truth table is just showing you that an and statement is only true if both of the conjuncts are true. You see that, right? Again, what's the truth value of the complex statements? Well, it depends on the truth value of the individual statements. For an and statement, for a conjunction, both sides have to be true. I'll wait just a second to give you an opportunity to respond to this. This kind of thing is a lot easier if I have a blackboard and I can really point to things. It's very hard for me to go back to the slideshow to try to go over it. I do want you to, this is a crucial part that I want you to understand. Yeah, you probably just need to practice them, but try not to just look at the table and try to memorize it. Try to understand the logic of it, right? Try to understand that this is modeling how we use language already, how we use and statements and how we evaluate them, right? You all knew when I asked you intuitively, if I tell you that it's sunny and hot, you intuitively know that to judge whether or not that statement is true, both of those things have to be true. If one of them is false, the whole statement is false. You know that intuitively. That's what this truth table is showing you. The truth table is showing you, well, let's look at the possibility when P or Q are both true. Aha, then you've said something true. But if P is true and Q is false, you said something false. If P is false and Q is true, you said something false. If they're both false, you said something false. Okay. Do you only do truth tables? No, we'll do the truth tables with the other ones as well. Right? We're going to define each of the four operators. So you're basically learning the rules for how these operators work. And it's really best if you can get an intuitive sense so that when you are looking at this truth table, at this diagram, you understand that it's showing you what you're telling me. Again, I'll ask you again. If I tell you that it's sunny and hot out, when would you call me a liar? Maybe you would never do that, but how would you know that I said something false? Well, if either of those things isn't true. Yeah. If both or one of the statements is false, then the whole statement falls apart. And that's what that's what this truth table is showing you. Right? Notice that middle column. That's the truth value of the whole statement, right? When I tell you, hey, it's sunny and hot out, and you're trying to judge, is that statement true? Well, the middle column shows you all the different possibilities, right? And it shows plainly, if you look underneath the P's and Q's, if there's a false underneath either the P or Q, the whole statement is false. It's only true if both of the things I said were true. And that's what the truth table shows you. So everyone's able to answer my question very easily, right? When is my statement true? When they're both true. Now just connect that understanding, that intuitive understanding, to this truth table. Maybe you can't do it right now, right away, with all the pressure, but that's what you need to do, right? You need to connect your intuitive understanding of how and statements work and how you judge them to be true or false. You already know this. You already know the truth table. You just have to get used to representing it in this symbolic form. You know. So now let's contrast that with or, right? We already noticed that or is different, isn't it? What does it take for an or statement to be true? Yeah, just only one of the things has to be true. And again, that's what we see. I'll switch over to the slideshow again so I can highlight. We see the same thing, right? A P or Q statement, it is going to be true as long as at least one of them is true, right? And we see that. We see that it's very easy for an or statement to be true. It's true if both P and Q are true. It's true if just P is true and Q is false. And it's true if P is false but just Q is true. As long as at least one of the things you're saying is true, then the whole thing is true. But if both of the things you're saying are false, right? If you look outside and it's not sunny and it's cold, right? If both statements are false, then you would judge my statement to be false. You know? So we can see that the or functions differently, right? We have the T's and the F's exactly the same over here. We use the same trick, right, to represent all the different possibilities. You just go T, T, F, F, T, F, T, F. And that way you've represented all the different ways that P and Q can be true or false together. Just like the sides of a coin, again, right? It's the same sort of thing. But this middle column is different than it was for the conjunction. Right? Because conjunctions are much harder to make true, right? In a conjunction, both sides have to be true. Whereas in a disjunction, only one side has to be true to make the overall statement true. Right? But if both are false, then the whole statement is false. Okay, let me go back. Yeah, so close. Yeah. So that's a disjunction. Conditionals are a little trickier, right? So I'm hesitant to move too quickly. I want to give you an opportunity to really make that connection here, to really see what this represents. I mean, people had some concerns about not getting the middle row? Are there any problems about that? You understand why there's just 4 possibilities, right? And it's not arbitrary that there's just 4 lines. Those are just all the logical possibilities that there are for 2 statements to be true or false together. Just like you have 2 coins, how many different ways can they land? There's just 4 ways. So then we're just saying, well, given these different ways that P and Q can be true or false together, what does that say for the overall statement? Right? And so the middle row just represents the truth value of the overall statement given the truth value of the individual simple statements for each row. So again, let me go back to here. And when we have this, it's sunny and it's hot out. This first row right here, right? There's 4 separate rows. These are columns, of course, right? So this column represents all the different truth values for P. It can either be true or false. And Q can either be true or false. But then, of course, they can be true and false in different ways, right? So P can be true and Q is true, or P is true and Q is false. Right? Or P is false, but Q is true, or P is false and Q is false. Right? So these are just the different logical possibilities. And then we go through the rows. We look at each of those logical possibilities. Let's say, okay, so let's suppose I told you P and Q, right? And remember, P is a true or false statement. Q is a true or false statement. Now, let's forget about sunny and hot. Let's just let these represent any statement at all. If I say P and Q, and P is true, and Q is true, then the whole statement is true. And the whole statement is represented right here. But now let's look at another logical possibility. Maybe when I say P and Q, P is true, but Q happens to be false. That's another logical possibility. In that case, the whole statement is false. Let's look at another logical possibility. What else is possible, right, for P's and Q's? Well, maybe P is false, but Q is true. What does that do to the whole statement? Well, it's still false because everyone recognizes intuitively that a P and Q statement can only be true if both sides are true, right? So let's look at our final logical possibility where P is false and Q is false. They're both false. Well, then the whole statement is also false, right? Because again, a P and Q statement, everybody agrees, I know you get this part, both have to be true in order for the whole statement to be true, okay? And same here for the disjunction. You just do the same thing. We're looking at all the logical possibilities. Again, look, these look exactly the same, right? P could be true, but Q is true as well. Or P is true where Q is false. Or P is false where Q is true. Oops. Go back. Okay. Or P is false and Q is also false. But this time, because we're using a disjunction, we're going to get a different value right in the middle for the whole statement. Because for a disjunction, as long as one side is true, as long as either P or Q is true, then the whole statement gets to be true. And again, this is something you know intuitively, right? You all agreed when I asked you, right? What would make a P or Q statement true? Well, as long as either P or Q is true, the whole statement is true. That's why we have 3 T's right in the middle right here, right? Because these are all the logical possibilities where either P is true or Q is true or both. An or statement, a disjunction, is only false in this logical possibility, where both P and Q are both false. Yeah. So yeah, you sort of look at the sides and think about the meaning of the operator, how it works, and then you can decide, is the whole statement true or not? Yeah. Look at the truth value of the individual statements, look at what the operator does. So we're just sort of codifying the rules that you implicitly already know just by speaking English, right? So it's weird to think you already know this. I just want you to be able to represent it symbolically like this, and this also will sort of count as a rule book for doing logic, just to remind you how each of these operators work. But really, you already know how they work, right? It's simply looking at the different statements that you're making, how many different ways can they be true or false together, then what's the operator. Depending on what the operator is, then you get a different truth value for the whole complex statement. Yeah. Right, yeah, exactly. Your brain's that you can just do all this stuff, right? Again, psychology is full of heuristic devices. But we are following, in many cases, a sort of an implicit logic, you know. But that's the whole point of making it explicit, so you can see what you're doing and also make sure you're not making a mistake, right? So that's a disjunction. Now, what about a conditional? Conditionals are a little bit weirder. They're a little bit less intuitive. If you just look at the chart, you can see how it's different from the other ones, right? You see how this is a little bit more, if you look at the middle row, right, before I explain to you the logic of it, if you look at the middle row, it's kind of more like the disjunction, right? Because it's quite easy for a conditional to be false. Notice, when is a conditional false? You might as well remember conditionals this way. Conditionals are only false in this row right here. A conditional is only false when you have a true antecedent and a false consequent. Well, why is that? Well, because that's the very thing that you're saying the opposite of when you're saying if P then Q. When you say if P then Q, you are saying whenever P is true, Q has to be true. Right? So then if we see an instance where P is true but Q is false, then we know that the whole statement is false. In all other cases, it gets to just be true. That's the part that's a little bit weird and less intuitive maybe than the other examples. It works well if you have the right kind of sentence. So, for example, this statement: if you give me $1 million, then I will eat a worm. Imagine this statement for yourself. Is this true for anyone? Would you do it? Would you eat a worm for $1 million? I think I would. Would anyone not? Right. Eat one for less, yeah. Sure. So, let's take this as a true statement then. It's a true statement. Yeah, if you give me $1 million, then I will eat a worm. It's true for me, it's true for you. All right. Is that statement false now because I didn't give you $1 million and you didn't eat a worm? Well, we just agreed that it is true, right? You would eat a worm if somebody gave you $1 million. Now, but you're not eating $1 million and nobody's giving you a worm. Or you're not eating a worm. But the statement's still true, isn't it? Let's do it a different way. Let's go through each of the logical possibilities. Okay? Like we did for the other one. So, remember, these represent all the different ways that P and Q can be true or false together. It's set up in the same way again, right? P could be true, but it could be true where Q is true, or it could be true where Q is false. P could also be false, but P could be false where Q is true, or P could be false where Q is false as well. So now let's look at our statement. Let's say I do give you $1 million and you eat a worm. Then the statement is true, isn't it? That would be real good proof of it, right? That's proof is in the pudding, right? That would be really good proof that the statement is true. If I give you the $1 million and then you do also eat the worm, then it would definitely be true, right? But what if I gave you that $1 million and then you didn't eat the worm? Then the statement would be false, right? Then you made a false statement. You had said, if I give you the $1 million, then I will eat a worm. But now I'm giving you the $1 million and you're not eating the worm? You've said something false. Everyone see that? But let's look at the other possibilities. What if I don't give you $1 million, but you do eat the worm? Does that affect the truth value of your initial statement? No, right? You're free to eat a worm right now for no reason at all. Like somebody said, you've done it for less. You could eat a worm, that's fine. Your original statement still stands true. Hey, if you give me $1 million, I'll also eat a worm, right? the statement is still true. Even though I didn't give you $1 million and you are eating a worm, the statement is still true, because if I gave you $1 million, then you would eat a worm. And what if right now, this is the scenario right now, right? I'm not giving you $1 million. I don't think any of you is eating a worm right now, I assume. Okay, let me go back so I can see what you're saying. So that fourth one, yeah, exactly. A conditional is always true unless it has a true antecedent and a false consequence. In other words, what would disqualify your claim that you would eat a worm if somebody gave you $1 million? There's only one scenario that really disqualifies that. That's the scenario where I give you $1 million and you don't eat the worm. That would disqualify your statement. In all other cases, it's true, because look, right now, I'm not giving you $1 million, you're not eating any worms, and yet it is true that if I give you $1 million, you would eat a worm. Does everyone see that? It's a little more confusing than the ands and the ors, but still intuitively this makes sense. Right? You understand that an if-then statement, the only scenario where it's falsified is where you have a true antecedent and a false consequence. Okay, so this is the one where it's slightly more difficult to get you to intuitively see how the conditional operator works. But if you use the right kind of example, it does make sense. Again, when you're maybe go over this on your own, look at the Prezi without me talking over it, and sort of look at these tables until they make sense, right? And again, just you can just go through them as these scenarios, little scenarios for yourself to ponder, right? Here's 4 different scenarios. In one scenario, somebody's giving you $1 million and you're eating a worm. Well, does that make the statement true? Yeah, exactly. That's exactly what you're saying, that if P is true, then Q is also going to be true. What about in the scenario where P is true but Q is false? What if I give you $1 million but you don't eat the worm? Well, then your statement was false. You said you would eat a worm if I gave you $1 million. Your statement is false. Right? What about this scenario? Another possibility, right? We're just pondering logical possibilities. Right? What if I didn't give you that $1 million, but you do find yourself eating a worm? It does not affect the truth value of your statement at all, right? It's still true that you would eat another worm for $1 million, if that's what you had originally said, all right? And if you haven't changed your mind about it, right? And also, the bottom possibility, that's a possibility. That's the actual situation, isn't it, right? When you're thinking about logical possibilities, doesn't the bottom one represent the possibility that we're actually in right now? Am I giving any of you $1 million? Is anybody eating a worm? Well, yeah, I doubt it, right? This is the scenario that we're actually in, is the bottom scenario, right? Remember, these are all just logical possibilities. Some logical possibilities are real, right? The logical possibility where nobody's eating a worm, nobody's getting $1 million, that's our reality. That's the possibility that's actually a reality. Notice, we are perfectly fine saying in that reality, even though the antecedent and the consequent are both false, we're fine saying, if you give me $1 million, then I will eat a worm. Right, exactly. Yeah, that's the reality we're actually living in. And so you can see that maybe it sounds weird to think that P and Q are both false, but the whole statement is true. That sounds, when you're looking at it like this, sounds weird and counterintuitive. Yet, when I remind you that this is actually the scenario that we're in, it's not so weird. Again, is this statement true for you? If you give me $1 million, then I will eat a worm. Most of you said yes, you would eat a worm for $1 million. True statement. It's still true, even though nobody's giving you $1 million and nobody's eating any worms. Right? It's still a true statement. So I'm just saying that because you might look at this chart and think it's weird that it gets to just be true all the time, except in that one possibility. Well, that's just how if-then statements work. And if you really thought about them long enough, you would see that. Yeah, it is confusing. It can be confusing to people. But is it confusing when we're talking about the $1 million and eating the worm? If you forget about the truth table, and I just point out, I'm not giving you $1 million, you're not eating a worm, but it is true that you would eat a worm for $1 million. You can hold those thoughts in your head, right? That makes sense? Yeah, so it gets hard to think of all the logical possibilities, and when you see them all laid out like that, it can get confusing. But that's why it's still best if you can get the intuition behind it. Yeah, the third one down, why that's still true, right? Where the antecedent is false and the consequent is true. So does everyone see that? Rachel is asking, what about the third possibility there? Where the antecedent is false, right? P is false, but Q is true. Why is the statement still true? Well, again, ask yourself. How firmly committed are you to the idea that you would eat a worm for $1 million? Pretty firmly, right? That's true. Let's say that's just unbreakably true, right? Now, but what if right now, while this is true for you, right? You go out to the yard really quick and pop a worm in your mouth. Would that affect the truth value of your statement at all? No, right? I mean, unless you're thinking like it might make you so sick that you can no longer eat a worm. But if you're not worried about that, it doesn't matter. The statement is still true. You're free to eat as many worms as you want. It's still true that you would eat one for $1 million. Right? So that's why the third one is still true. Just keep on eating worms. So that's why the third one and the fourth one are still true. When you look at it, I grant it is confusing. This is why I spent a little bit of time on conditionals, because they get confusing. Now, as a last resort, you can always simply memorize each of the 4 truth tables. The P's and the Q's are always going to be the same, right? It's always going to be TTFF, TFTF. Those represents all the different ways, all the different coin flips, right? The way two different coins can land. Right? 2 different statements can be true or false together. That's always going to be the same. And then each of the operators will just have a slightly different line to indicate the truth of the whole statement. Worst comes to worst, simply memorize it. It's better if you understand how it works. Yes, Anna, yeah. If you just have 2 variables, that's always how it's going to be. If you have more than 2 variables, that's where it gets tricky. Then it starts doubling every time, right? So if you have 3 variables, you've got 8 logical possibilities, right? In that case, you would start with T, 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 F, 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 T, T, F, F, T, T, F, F, T, F, T, F, T, F, T, F, T, F, right? If you have 4, you'd have 8 T's in a row, right? 8 F's in a row, then on the next one, okay, I won't confuse you too much with that. But when you have 2 single variables, there's always going to be only 4 different possibilities, right? It's, again, 2 coins. How many different ways can they land? Assuming they're always landing flat, right? No silly counterexamples where they land like this. When coins land flat, if you have 2 coins and you lay them down just by chance, how many logical possibilities are there? There's only 4. Right. So going TTFF, TFTF is just a convenient way of showing all the different ways that they can combine. It's showing all the different logical possibilities. Right? It's like saying heads, heads, tails, tails, heads, tails, heads, tails. Then you would have all the different logical possibilities in front of you. Instead of heads and tails, we're doing true and false. But the same principle applies. There's only 4 different logical possibilities. And so those are best represented just very easily. So we all do it in the same way by going TTFF, TFTF, like that. Yeah. Okay, so does the conditional make a little bit more sense then? Yeah, in the middle column, Stacy, you're right. The middle column will always be slightly different depending on which operator you're using. Yeah, that's why I call these the rules for the operators, right? The P's and Q's, that all stays exactly the same. It's just a grid of the logical possibilities. But then, depending on the operator you're using, the truth value of the overall statement is different, right? Because again, look, the P's and Q's are exactly the same for each of these. It's the middle row that's different. And the middle row just is depending on what the operator is doing to the entire equation. Right? So the and the or, I've said, these are really pretty intuitive. You already know that an and statement is only true in that top row, where you see T for P and T for Q. Because both sides of a conjunction have to be true for the whole statement to be true. So you can just memorize that rule, right? A conjunction is only true if both sides are true. And in all other cases, it's false. So you put a T right at the top and F's right down the bottom. Because in every other scenario, one side is false. And you can't have that in a conjunction. You can in a disjunction, right? For a disjunction, the rule is at least one of the sides has to be true. At least one of the conjuncts has to be true. And as long as at least one or both is, the whole thing is true. And that's why you see a bunch of T's right down the middle, but only an F at the bottom, because that's where both sides are false. That disqualifies an or statement from being true. And the only thing that disqualifies a conditional from being true is that second row, where you have a true antecedent and a false consequent. That's the only time that a if-then statement is going to be false. And there are examples that look weirder than the example that I used. The example I used is a lot more intuitive. This idea that, well, you know you'd do it for $1 million. Make it even easier. Let's not talk about worms. Let's just say, if you give me $1 million, I will take a sip of water. This is true for everybody, right? I should have just done it like that. Just make it even simpler. What's the only scenario where it's obvious that your statement is not true? It's only if I'm giving you $1 million and you're still not taking a sip of water, right? Yeah. It does not matter that you might sip water now, right? The statement is still going to be true. It doesn't matter that I'm not giving you $1 million. The statement is still true. Yeah, so if you have to just memorize the rule, memorize that for the conditional. A conditional is only false when the antecedent is true and the consequent is false, right? When the first part is true and the second part is false. When P is true and Q is false. That's the only time that a conditional is false. Okay? Almost done learning the basic rules of the operators. Thankfully, the last one is very easy because negations, they don't join together multiple statements. They only are true of a statement. Right? They don't connect statements like the connectives do. So here, it's pretty simple. Again, you look at all the logical possibilities. Now we're suddenly using with just one coin, right? How many truth values are there for a single statement? Well, they're either true or false, right? So when P is true, then not P is false, right? When P is false, then not P is true. You see that? It just flips the truth value. That's all it does. Negations are funny because they're really the simplest of the bunch, but they also cause a lot of confusion sometimes. Okay? But that's all a negation does, right? So, for example, let's say P represents it's sunny out, right? And it is sunny out right now, right? So then if I tell you, right, so P true, that's the first logical possibility, right? Or P is true. So that means it is sunny. Then if I tell you it's not sunny, I would have said something false. Right? Whereas if it's false that it's sunny, then when I say it's not sunny, I'm right. I'm saying something true. So the negation there just flips the truth value of the simple statement into its opposite. Oops. Wrong button. Okay, so how are we doing? How's the negation? Negation weirder for anyone? I mean, it's when you see it like this, it's pretty simple. If you just remember, it just makes it into the opposite, right? Yeah. So a negation is only true if the simple statement is false. Right? It's a little weird. But a negation just says the opposite, right? It makes it into the opposite. I somehow lost my remote on the Prezi, so hold on one sec here. Okay. Well, then I guess we should stop right there. I was going to keep going, but it is time, and I don't have exercises right here. And it might be good for you just to study those truth tables for a little bit, right? To sort of get the intuitive aspect of it that I've been saying. That's going to help you out a lot. Rather than having to memorize these truth tables as these rules, it's a whole lot better just to sort of get what each of the conditionals or what each of the operators does. Okay? So, you know, I don't know why I haven't done this in the past. I might try to add this, just a quick one sentence rule that helps to remind you, right? So a conjunction is only true if both sides are true, right? You can see that in the chart right here. Only in the first row, you have P and Q both being true, right? So a conjunction is only true if both sides are true. A disjunction is only false if both sides are false, and it's true in all other cases. Quick ways to remind you, right? So it's a quick rule for saying that something is either only true or only false, and then you can simply fill in the rest, right? So a conjunction is only true when both of the conjunctions are, well, both of the conjuncts are true, when both P and Q, when they're both true. So once you know that, you know, okay, put a T for that, and then all the other ones are going to be false by default. It's only true in that one scenario. You can do a similar thing for a disjunction, but just focus on the only time that it's false, right? To quickly remind you, well, disjunction is only false when both of the disjuncts are false, when both P and Q are false, and it'll be true in all other cases, right? That captures your intuitive understanding of and or, and then I want you to look at the truth table to see that it's represented right there, right in the middle row, right? The middle row is telling you, yeah, you're right. An or statement is only false when both sides are false, when both of the things you're saying are false, right? And the same thing for a conjunction, right? That middle column, sorry, I call it row sometimes. It's a column, the middle, the one right in the middle like this, right? The middle column is telling you, your intuition back to you, that an and statement is only true if both of the things you said are true, right? That's why there's only a true in the top part of the column. Right? That's the part where both sides are true. And it's false in all other cases because there's a false on one side. Right? So these truth tables are capturing your intuitive understanding of and or statements. Theoretically, the same thing is going on with conditionals, but conditionals are a little bit trickier. They're a little bit weirder when you think about them in the abstract But simply then, if you can't quite get the intuitive part of it, just memorize the rule. A conditional is only false when the antecedent is true and the consequent is false. Right? When the first part is true and the second part is false. Right? That second row right there. That's the only time a conditional is false. Yeah? And then finally the negation, where it simply flips the truth value of the simple statement. Okay, any questions? I hope that brought some clarity to everything. And like I said, I think you should spend some time with those truth tables. There's only 4 of them, but just sort of start looking at them, start seeing why it makes sense, right? Start seeing why the F's and the T's are there, right? Start seeing that these simply represent the logical possibilities. Think of 2 statements that are both capable of being true or false, right? 2 statements are like 2 coins that can be true and false in different ways together. We're exploring the different logical possibilities. Yeah, sometimes it's like that, right? The negation rule just flips the truth value, right? So if P is true, then not P is false, right? So if it is sunny, and I tell you it's not sunny, you'd say that's not true, right? I just negated something true, so that makes my statement false. Or if you say something false, if you say it's snowing out, and I say no, it's not snowing out, then I would have said something true because I'm negating your false statement. Yeah, it simply flips the truth value to its opposite, right? So if a statement is true and you put a negation in front of it, then that brand new statement is itself false. Okay, stick around for a second. Yeah, right. Exactly. Yeah. Okay, good. I'm glad some of this makes more sense when we're talking about it. And don't get too far ahead yet, right? Just focus on the idea of these truth tables. Basically, just defining what those connectives do. How do they work? How does our ordinary language work, right? How do we reason using statements like and type statements or type statements? Okay, good. Well, then I shall see you on Tuesday. I hope you have a good weekend.
You are currently the only person in this conference.